Yes, welcome to Unit 2, Lesson 2, Part A. So we've already done two-step equations. So now we're going to make it a little bit more complicated, and we're going to do what we call three-step equations. That's when you're going to have variable terms on both the left and the right side of your equation. So you can see here we have a variable term. And for the variable term, I'm going to write VT. And we also have constants. So for constants, we're going to write C. So we have a VT, variable term, a constant, a variable term, and a constant. Now the problem is these are not like terms, so you can't combine these together or these two together. So we have a problem. We have a variable term on the left and the right. So we have to choose one to eliminate. So eliminate one of the variable terms. So we just have to choose, and we have to choose wisely, because if you choose unwisely, as you can see in this problem, if we eliminate the 11x, we're going to end up with a 0 on the left, and that's going to be a problem. I'll show you that in a minute. But let's pick 8x to get rid of. You can pick 3x if you want. So I'm going to subtract 8x. So we do the additive inverse twice. So this is additive inverse. The first one, where we have now gotten 0x over here. So I still want to have a vertical line, and I'm performing and I'm aligning to like terms. So these two guys are like terms. So I align them vertically like I would with place value. 3x minus 8x is negative 5x. And then you bring down things that you did not do anything to. So minus 7. Notice that the term is all of minus 7. So the subtraction is happening here. And I'm left with plus 23 on the side, but I don't have to write the positive plus 23, so I'm just going to get rid of that really fast. Okay, now you can see we have a variable term, a constant, and a constant. So I'm now down to two-step equations, and I know how to solve those. I do the additive inverse again. That's the second time I'm doing it. So I'm adding 7 because I want to get rid of the constant. And I add 7 to the left. And I'm performing the additive inverse twice. So I have that big bar going through. Minus 7 plus 7. Bring down the things that you did not affect. Negative 5x. I'm making sure that my sign comes with me. Equals. And 23 plus 7. These are alike, so I can add them. 30. And now I could divide by negative 5, or I could multiply by negative 1/5. Since it's an integer, I'm just going to divide by negative 5. Positive 1x equals negative 6, and I'm done. Let's see what happens if I accidentally, the smart thing to do here would be to subtract 8x. But let's say I subtracted 11x, because I have a variable term, a constant, and a variable term. So if I subtracted 11x, it's going to make more work for me. That becomes 0 equals 24. 8 minus 11x is minus 3x. Okay, so now I have a big problem. I need to get one of these things over here. So I could subtract 24. And you can see I've made more work for myself. Negative 24 equals negative 3x, and then I could divide by negative 3. Remember, the coefficient is negative 3, so I'm dividing by negative 3, because a negative divided by a negative gives me my positive x equals 8. What would have been smarter here, you'll see how much faster it will be if you do it the correct way. 11x equals 24 plus 8. Plus 8x. It would have been a lot smarter just to subtract the 8x here. And you can see now I have 24, and on the left I have 3x, and now I'm just dividing by 3, and x equals 8. So strategy is important on this. You have to look at your variable terms and decide which is the most strategic to answer. You can see how much more work this was compared to this problem. Okay, let's do 2 more. 6n minus 1 equals 4n minus 2. So I have a variable term and a constant, a variable term and a constant. I'm going to subtract 4n because I like to have positive variable terms. So with coefficient being positive, 6n minus 4n is 2n. Remember, the alignment's really important. You align to like terms. So that's 0. Minus 1, remember the sign, equals negative 5. Now I'm at a 2-step equation. I'm going to add 1. 2n equals negative 4. Divide by 2. And I get n equals negative 2. Okay, so now we get a fraction, coefficients here. The variable term, constant, constant, variable term. I can see that I have a dilemma here, that this is in thirds and this is in 6. So there's a couple different techniques to deal with this. One, we could just find you need to get, change the fraction so you have a common denominator. So I would rewrite this as 4 6x minus 1 equals 9 minus 1 6x. Now the coefficients are in 6. So I can add a 6x. It's the entire term. Add 1 6x. That's gone. And I'm adding these together. That's 5 6x minus 1 equals 9. Not very straight, sorry. Add 1 to both sides. Again, I do the additive inverse twice. 5 6x equals 10. And now I'm going to multiply by the reciprocal. 6 over 5. I get 1x equals 60 over 5. Or another way to write that is x equals 12. So again, you have to have a common denominator if you're going to add things together. There's one other way we could have approached this problem. 2/3 x minus 1 equals 9 minus 1 6x. We could have approached this problem and solved it a little bit differently. You could bracket both sides, or parentheses on both sides. 2/3 x minus 1, 9 minus 1 6x. We could have multiplied both sides by 6, and that will get the denominators will cancel out. So I get 12/3 x, because I got to fully distribute, minus 6 equals 54 minus 6 over 6x. Now I simplify, that's 4x minus 6 equals 54 minus x. Now I don't have to deal with any fractions, so I could add x to both sides, getting rid of it on the right. 4x plus x is 5x minus 6 is 54. So I simply just need to add 6 to both sides. And I get 5x equals 60. And with mental math, or dividing by 5, it's 12. Either way, there's going to be lots of other techniques that we can learn. But this is variables on both sides, 3-step equations.